good morning. My name's Jeff Osborne. I'm with ISC, you know us from Bind and the operators of the F-Route. I'm also the chair of the Root Server System Advisory Committee at ICANN. So ISC, like RIPE, is an operator of a root server. You've got the K-Root, we've got the F-Route. And one of the issues that we've found is really pretty widespread. The engineering free reign we've had for the last few decades of how to run the internet is sort of ending, and the legislators and regulators and government controllers are becoming more and more important. So something we're finding is the laws are being put in place, and what we need to do is figure out how to talk to the lawmakers before bad laws get made. So in order for somebody to understand what they need to do and how to legislate around the DNS and the root server system, they've got to understand what is DNS, what is the root server system. We sat around and talked about this and realized most of us who have been in this industry for a very long time, and I've been involved in the commercial internet since 1983, my mom doesn't know what I do for a living, never has. My wife has no idea what I do for a living. And I have a lot of smart friends with master's degrees and doctorates who are brilliant in their fields, have no idea what I do for a living. So we realized we were going to be talking to very intelligent, very well-educated people about something they know nothing about and having to explain it in the short time frames that they'll give you in a way that's both meaningful and actionable, and this is hard. So I've got a lightning talk time frame, so rather than give you the full presentation that we're providing, I wanted to have a meta presentation. So I'm trying to establish here in about 5 slides, this is the problem set. This is what we think we're trying to do. And if you're interested, and as a RIPE community member, you want to help out, the last 21 slides in the deck are, this is the thing we're actually giving to them. So I'm telling you the prep part of, this is our problem. And then if you're interested, you can go from slides 7 to 28 and see, aha, this is how they're going to present it, if that makes sense. So again, the problem set is most policymakers don't understand the root server system, and some of them are going to have to understand it, not just theoretically, but operationally. The usual way you explain DNS makes sense from an engineering point of view, but translates poorly, unfortunately, into politics. So if you think about it, you've seen first you ask the root, and then you ask the TLD, and then finally you get to the domain name. Well, that makes sense logically, but it's not really operationally the way things work. Nobody ever walks into a cold, dead internet and starts it up from scratch. You know, there are caches and everything that already work. This makes it look as if that root server is the beginning step and is vitally important to every action that happens and introduces all kinds of latency. And, you know, we're given the idea of there's 86 million milliseconds in a day. Latency is not really an issue. Everybody's going to know this stuff when it's warm. It also understates the operational significance of the public resolvers, the quad 1, quad 8, quad 9, all those things. So what's the problem with that? The problem is this all creates the false impression that the root servers are the gatekeeper to the internet. The American term is on-ramp, the English term is slip road, whatever you want to say. The idea is it looks as if this is a controlling factor of anybody being able to use the internet. The term hierarchy in engineering makes a whole lot of sense when you're looking at this, but to a politician, they hear hierarchy, and every one of them wants to be at the top of the hierarchy. So it fails to correctly describe the way this works. The idea of being a gatekeeper means you're the first place where the errors can happen. And we really need to explain this is a system that hasn't had an operational failure in 40 years. The root server system is comprised of over 1,700 instances with Anycast. The operators run 12 different organizations on different hardware platforms, different operating systems, different DNS implementations. And so it's hard to imagine an institutional or technical point of failure. So the solution is we we're trying to explain the way this looks in a real world where there are caches and they're all full. The first thing that really happens is not that you go and figure out what's the hints file look like. What really happens is you show up, there's a cache, and over 90% of the time, the resolver knows your answer. Then in a less likely case, you've got to go figure out the domain names. In a less likely case than that, you've got to figure out the TLDs. And in what we estimate to be about 1 in 5,000 to 10,000 queries, you go to the root. So this is literally a 0.02% query. So rather than being the first step before anything happens, it's a very unusual thing. This is the t-shirt component of this presentation in my last minute. I don't yet have a t-shirt with this on it, but I want it. In the millisecond world of resolvers, queries to the root system are rare. That's sort of the takeaway we want to leave people with. So how are we going to present this message? We have a document we've been putting together that's about 15 pages that most of you would find interesting, I think. It's trying to make it relatively digestible but complicated. And then the deliverable 2 is what I'm trying to do to take that and make it into an introductory level thing. This is something you could show a family member who wasn't technical, and they would get a grasp of what you do for a living. Finally, your spouse or partner or parent might know something. And then when they say, hey, go dig into it deeper, we've got the first deliverable. So this is what we're attempting to do. We're doing it on behalf of all the root server operators. And if you as part of the RIPE community would find that interesting, we would really appreciate taking a further look at it. And in my 4 seconds, I'll show you, here's the 21 slides. Summary, thank you very much.